So the first question in our today's session, I'm going to type it here. Very easy questions. Calculate the potential of hydrogen electrode H2 electrode, okay, hydrogen electrode in contact with the solution. The solution whose pH is 10. So this is the question. So I want everyone to attempt this and send me the answer to my WhatsApp. Yeah. So I'll be waiting for the answer. So this is the application of the SHE, she. The standard hydrogen electrode is there, right? That same thing. It's a very easy question to begin with. This can be done in seconds. Okay, fine. I'll do it. Okay. So those who are doing, they can do it, but I'm doing it now. Fine. So the main thing in this question here is the pH of the solution. Correct? If pH value, what is it given? 10. What is the meaning of this? Correct? The meaning of this is H plus ion is equal to what? 10 power minus 10 m. Now coming back to our main thing, Nernst equation. What is our Nernst equation? So according to Nernst equation, so we should write down what is our Nernst equation here. What is it? E H plus bar H2 equal to standard hydrogen SHE, right? The standard electrode potential of hydrogen. Standard, in the sense this is not button. E naught of H plus bar H2 minus 0.0591 by N log of 1 by H plus. Log of 1 by H plus, because in the numerator we always take it as unity. Correct? Also, we know what? We know this value. This value which is circled in yellow color, what is the value of this? 0. I clearly told that the standard electrode potential of hydrogen electrode is equal to 0. And what is my N value? N value will be 1. Correct? Hence it will be easy for me to calculate. N value is 1. Correct? And this value is 0. So what is my E? E of H plus bar H2 is equal to 0 minus 0.0591 by N into 1 by, what is H plus? 10 power minus 10. So if, and don't forget about the log here. Yeah, the log. Correct? So what I will get here? Minus 0.0591 into log of 10 power 10. Which means it is what? What does this mean? It is log of 10 power 10. In the sense, log of a power b. What is it actually? B log a. So similarly, log of 10 power 10 is what? 10 power 10 is equal to 10 log 10. But what is my log 10 value? Log 10 value is 1. Log 1 value is what? 0. So which I have clearly shared with you in the previous video. Correct? So similarly, putting this value, what is 10 log 10? 10 into log 10 value is, log 10 value is 1. So 10. Correct? So substituting all of these values here, what I'll get? Minus 0.0591 into 10 log 10. This is 10 power log 10, log 10 power 10. I'm writing as 10 log 10. So this is log 10 value is 1. Correct? So what is the value of this? This is nothing but minus 0.591. So E value is nothing but what? Minus 0.591 volt respectively. So this is the answer for this. So guys, coming to this problem, if I want to just put it in short, correct, calculate the potential of hydrogen electrode in contact with a solution whose pH is 10. Very easy problem. Only thing is that we have to know the Nernst equation. What is the Nernst equation? Correct, the general formula, E is equal to EMF. Correct, the maximum voltage of that particular what cell. EMF is equal to standard electrode potential minus 0.0591 by n log of 1 by, here it is H plus. H plus value already we know, 10 power minus 10. So 10 power minus 10 will go to the top, it will become 10 power 10. What is log of a power x? X log a power b, b log a. So here it is 10 log 10. Log 10 value is 1. So log 10 value is almost 1. So this is 10 into minus 0.0591. So 10 into this is what? 0.5 minus 0.591. That's it. This hardly needs 20 seconds to answer. That's it. So done. Okay, perfect. Okay, perfect. I'm going already. So before going to the next question, there's one more topic I have to take. Yes. After the Faraday's laws is there, right? After that thing. Correct? So I haven't touched few things. The cells. Correct? Cells in the sense, the commercial cells. Very easy for us to identify these things. Very interesting also to know the mechanism. Commercial cells. So first thing, coming to the commercial cells, I'll deal with what, what, let it be, yeah, let it be our the battery itself. Okay, or else let me say take the dry cell. First one I'll try to take dry cell or the Leclanché cell. Okay, fine. But the only problem with this kind of cells, correct, whatever cells I'm going to discuss, we all know what is it. Once we use the cells, we cannot reuse. We just throw it away. That's it. It's not rechargeable. Correct? Yes, we cannot recharge. But again, coming now, there are some cells where we can argue that we can reach 100% agree. But we should very importantly note a point that the book which we are studying is around 1920 or 1990. Okay, or 1920s. You got the point. So the that same thing only we are actually I'm teaching and you are learning the same thing. Correct, but the one which is given for us now is what we cannot use. But nowadays technology has improved so was that we can obviously reuse it. We are using new technologies. It be in the trimmer or even the electric brush, which is rechargeable. So a lot of things has come up. Okay, just wanted to guide you in the correct way. But end of the day, for marks, correct. So we have to study this. Coming to a dry cell or Leclanché cell. Okay, so coming to dry cell or so here also I'm using mainly zinc. Okay, dry cell or Leclanché cell, main thing is what zinc, in the sense if you see zinc, it is what anode. In the sense oxidation happens at zinc, just like our Daniel cell. So at anode, what it is? Zinc. In the sense, zinc will give what? Electrons. Zn2 plus plus 2e minus. But one of the other thing in the cathode here, okay, the cathode, which is very important for us. Okay, so coming to the cathode side of the dry cell, very important. It is manganese dioxide, MnO2, and ammonium ions. Okay. And if you ask me the electrolyte, what we are using in this? Okay. It's a paste of ammonium chloride, NH4Cl, and zinc chloride. So that is the main paste we are using here as a electrolyte for the smoother conduction. So coming to the cathode reaction here on the top, it is MnO2 plus NH4 plus, and it will take the electron. I'm not balancing here. It will take the electron from the zinc, or else I can put 2E minus. It will give us what? MnO2, but it will give a hydroxide ion of the same, OH twice, and ammonia as a byproduct. And we all know what is a dry cell, or let's take an ordinary battery. What is the cell potential? Cell potential or EMF is what? 1.5 volt. The cell potential of this is 1.5 volt. So in this particular thing, we have to just remember only two things. First thing is anode. What is that anode? Zinc is there. Cathode consists of what? MnO2 and ammonia. And it takes the electron from the zinc to produce this complex compound. Yes, correct. And one more thing is, what will happen to this Zn2 plus? This Zn2 plus will react with this ammonia to form a complex. That thing I'll show you, which is not required for us, but still I will show you. Zn2 plus plus this ammonia, the byproduct which you'll get, right? I'll put this to balance it. I'll get zinc NH3 4 times 2 plus. So this is a complex. So if I want to write this complex, I'll write what? Zn NH3. Here also I'll write for NH3, NH3, and NH3. So you may ask me what I'm writing this. So this again in your chapter, coordination compounds. Correct? And these four NH3s, this is called ligands. These NH3s are called ligands respectively. And like this is not available in your textbook. So these are called ligands in the sense it can share the electrons with the Zn. And zinc, let me circle the zinc value here. So I told you what is this NH3, so those are called ligands. What about this zinc? This zinc is called central ion or central metal atom. Central metal atom or ion respectively. So all of this in detail we will learn in coordination chemistry or coordination compound chapter. But if you read a textbook now, you can't find ligands nor this thing. Okay, this diagram you cannot find in the textbook or anywhere for this particular chapter. So things to note down is these two things. This one and this one, the cathode, the two things. So coming to our next one, the one which we use in our watch. I'll write in the application first. Correct? Watch, that will be fine for us. Correct? Watches. So what is the cell which you are using? We all know what is the cell. Most of us know. Mercury cell. A small cell, small battery, right? Correct? So here the important thing is what is the anode and cathode. So for everything, we should need what? Anode, cathode. So anode is nothing but zinc mercury amalgam. In the sense a paste. Amalgam. Okay. Cathode. Anode is this thing, cathode. So cathode is nothing but what? It's a paste. I'll write down here paste. It's a paste of mercury oxide and carbon at cathode. And if you ask me about the electrolyte here, the electrolyte is the paste of potassium hydroxide and zinc oxide and ZnO. Okay, and coming to the reaction point of view. So anode is, we all know zinc mercury amalgam, and cathode and electrolyte is follow. So let's take a reaction here. Anode. So anode we all know it is zinc. but it is ZnHg actually, correct? It's a combination of ZnHg. This will react with what? The hydroxide ions, two OH minus. Obviously, this will give out electrons, correct? To form what? Zinc oxide and water and electrons. Whenever zinc is there, electrons will be released. Fine. And who will take the electrons? The cathode will take the electrons here. Cathode will take the electrons. Cathode is what? HgO. Will take this electron, or also the water. Will take the water and the electrons produced at the anode. Correct? And this will give us Hg and OH minus ions. And this OH minus ions will further react with the anode. So this constant reaction only is our the functioning or working of a battery. Okay, so if you ask me what is the overall cell reaction of this? Overall cell reaction. I'll write down here ZnHg plus HgO. I'm cancelling out the electrons and water thing. Okay, we'll give ZnO plus Hg. So here, coming to this, if you ask me the cell potential of the mercury cell, it is almost same. 1.5 volt was our Leclanché cell. Here it is 1.35 volt. Cell potential is 1.35 volt respectively. 1.35 volt. So this is something where what you have to by heart and keep. Okay. So these are all my primary cells. I can call this as what? My primary cells or batteries. Commercial cells I told, but under commercial cells, these are all what? My primary cells. But if I had discussed about primary cells, then I will discuss about what? Secondary cells also. So let's take our home itself. Okay. Secondary cells in the sense, those cells which can be recharged. Which can be recharged. Correct? So the best example is our inverter itself, the home inverter. So let's see the working in that. Correct? Yes. So first thing is the lead storage battery in this. Lead storage battery. So that is nothing but the one which is used in our inverter at home. So anode is always the lead, because this is a lead storage battery. So no other thing is given. So anode is a lead Pb, correct? And cathode is also nothing but just like the SHE. So it is the lead packed with lead oxide. Packed with lead oxide, PbO2. PbO2, that is nothing but my lead oxide respectively. Okay, so lead dioxide, not oxide, that is PbO, lead dioxide. My bad. Okay. So coming to this, the electrolyte is a sulfuric acid. Let me write on the electrolyte here. The electrolyte here is what? Sulfuric acid, which is around 38% in this. Now let's see the reaction at anode and cathode. Okay. So in inverter, there are two things. What is it? Charging and discharging. Correct. So what is this discharge? I'll come to discharging. Whenever the inverter is being used, so whenever there is power cut, there is power cut. discharging. Correct. Or else I can say power cut in this sense. What is discharging? The battery is in use. Discharging in the sense the battery is in use. That is discharging. Correct. So coming to this, what is my anode here? The anode is nothing but the lead. Yes, the lead. What? Lead with the sulfuric acid. But coming to that particular thing, this sulfuric acid. So we all know that in our battery, there is inverter whomever is having at home. We know there is some chemical reaction in that. We'll put the distilled water and everything. Correct. So coming to this, the lead here. Yes, the lead will be reacting with what? Yes, the lead will be reacting with the sulfuric acid. Obviously, it's electrolyte here. Correct. Yes. So lead with this SO4 2 minus. So that is H2SO4 will give me what? SO4 2 minus and the hydrogen ions plus electrons. So coming to this, lead again react with this to give what? Lead sulfate PbSO4, and it will give away 2 electrons. And at cathode will take these electrons. Yes. So there is nothing but lead oxide forms the cathode. PbO2, lead dioxide forms the cathode. Yes, with the electrolyte SO4 2 minus, but I forgot to add the electrons. Yes, so which will give me what? Lead sulfate and water. And suppose if I want to balance the reaction, I'll add 4H plus. So this is nothing but my redox reaction thing. Okay, which you learned in class 11th, the redox reaction chapter. For balancing, we add H plus to the cathode. So the this is for the discharging. Correct? Yes, this is just for the discharging. For recharging, for recharging, cathode and anode are displaced. In the sense, lead which was the anode will become cathode, and cathode will become anode, vice versa. So this is nothing but for what? Our lead storage battery respectively. So the question here is calculate the EMF of the cell in which the following reaction takes place. E, by using our Nernst equation. Overall reaction in the sense, we find the anode and cathode and we just add it so that electrons will get cancelled. So this is a very simple question.